Adding and subtracting rational expressions. For example, 7x over 15y squared plus y over 18xy. So the first thing we're going to do, just like these were regular fractions, is to find the LCD, the lowest common denominator, of the two denominators. To start that, I'm going to look at all the factors going back to prime factors of each denominator. 15y squared can be broken down into 3 times 5 times y squared. 18xy can be broken into 2 times 3 squared times x times y. So let's see what we have, what factors we have between the two of them. So I have a 3. Now in 15y squared, but my 18xy factor has a 3 squared. And when we're looking for an LCD, we need to take factors with the highest exponent. Okay, I have a 5 in my 15y squared. I don't have a 5 in my 18xy, but I still need to include 5 in my LCD. I have a y squared, and my 18xy has a y. The y squared has the highest exponent, so I include that. Let's look over at the 18xy factors to see if we've missed anything. We have a 2, we need to include that in our LCD. We also have an x that we need to include in our LCD. So our LCD will be the product of everything that is circled. It will be 2 times 3 squared times 5 times x times y squared, or 90xy squared. So next, we're going to rewrite each fraction with the LCD as the denominator. So instead of 7x over 15y squared, we are going to write it so that it is over 90xy squared. So 15y squared times what gets 90xy squared? I would have to multiply it by 6x. So I will multiply my old denominator 7x by that 6x. Looking at the second fraction, what do I need to multiply 18xy by to get 90xy squared? 5y. So I'm going to multiply my old numerator y by that 5y as well. So simplifying, 7x times 6x is 42x squared over the 90xy squared, plus y times 5y is 5y squared over 90xy squared. 3, let's add or subtract, but in this case we're adding the numerators. Okay, well, we've got a numerator that is an x squared, a numerator that has a y squared. We're going to add them, but we can't really combine them together. So we end with 42x squared plus 5y squared over our 90xy squared. And that is our sum. Let's look at a second example. X plus 12 over 4x minus 16 minus x plus 4 over 2x minus 8. So we're going to use the same concepts. First, we're going to factor our denominators. So x plus 12 over, so if I'm looking at the 4x minus 16, do I have a greatest common factor? Is there something that divides into both 4x and 16? Yes, it's 4. And then 4 times x minus 4 gets us the 4x minus 16. Okay, minus x plus 4 over, then if I look at the 2x minus 8, again, we see a GCF of 2, so I could break that down into 2 times x minus 4. Okay, so now we're going to find the LCD, just like we did in the first example. I'm going to go through each set of factors, and the 4 can be written as a 2 squared. So the LCD needs to include 2 squared and x minus 4. There are no other factors in those two denominators. So 2 squared is 4, so I can rewrite it as 4 times x minus 4. I don't need to go and multiply it all through. In fact, leaving it factored will help us at the end if we were to have to cancel any common factors. Okay, so let's rewrite this like we did in example 1 so that our denominators are now 4 times x minus 4. Okay, that was our original denominator in the first fraction, so I just need to write the original numerator, x plus 12. Now, 2 times x minus 4 times what gets me the 4 times x minus 4? Times 2. So I'm going to multiply my old numerator times 2. So instead of x plus 4, I have 2 times x plus 4. Let's simplify that. The first fraction, there's nothing to simplify right now. And then I have minus 2 times x is 2x, 2 times 4 is 8. So I have 2x plus 8 over 4 times x minus 4. Okay, now we're going to subtract the numerators. So I have my common denominator, my 4 times x minus 4. We're going to write x plus 12 minus 2x plus 8. And with the rational expressions, having it in a separate fraction implies the parentheses that you see written here. So I'm going to need to change the sign of each of those terms in parentheses. It becomes x plus 12 minus 2x minus 8. So let's simplify. What's x minus 2x? Negative x. What's 12 minus 8? Positive 4. So I have negative x plus 4 over 4 times x minus 4. Now we would want to see if we could simplify this at all and then cancel any common factors. Right as it's written, nothing's identical, but this negative x plus 4 looks like our x minus 4, very similar, except all the signs are changed. When that happens, when everything is identical except for all of the signs, I can rewrite that as negative times x minus 4. It's like I'm pulling out a common like a greatest common factor of a negative 1. So negative times x is negative x, negative times negative 4 is positive 4. They're equivalent. And now if I'm looking at negative x minus 4 over over 4 times x minus 4, the x minus 4's will cancel and leave 1's. And I'm left with negative 1 over 4. And that is my final answer in this problem. Let's look at one more example. X minus 4 over x squared plus 2x minus 8 minus x plus 2 over x squared minus 16. So again, we'll start with factoring the denominators. X minus 4 over, now I need to factor x squared plus 2x minus 8. I need two numbers that multiply to negative 8 but add up to positive 2. And I will get positive 4 minus 2. So the first denominator factors to x plus 4 times x minus 2. Minus x plus 2 over, okay, here we've got a perfect square, minus in between. So square root of x squared is x, square root of 16 is 4, one gets a plus, one gets a minus. So the second fraction becomes x plus 2 over x plus 4 times x minus 4. Let's find our LCD. So we have an x plus 4 factor, and I see it in my second denominator as well, but I don't have any exponents, so x plus 4 is definitely in my LCD. I have an x minus 2. That's not in our second fractions denominator, but I will need to keep it in the LCD. And in my second fraction, we already have the x plus 4, but I don't have my x minus 4 yet, so we'll include that as part of the LCD. So my LCD will be the product of x plus 4 times x minus 2 times x minus 4. I'm going to leave it factored like that. We're now going to convert our fractions. So we're going to convert the first fraction so that it has our LCD. I'm going to look at my original denominator and what is the additional factor? What else am I multiplying by in my new denominator? X minus 4. So I'm going to need to multiply my old numerator by that x minus 4. So now my numerator is x minus 4 times x minus 4 over x plus 4 times x minus 2 times x minus 4. Minus, so let's look at our old denominator and our new denominator. What extra fraction, or what extra factor do we have now? We now have an x minus 2 that we need to multiply by. So our old numerator, x plus 2, will get multiplied by that x minus 2. Okay, so let's simplify that a little bit. X minus 4 times x minus 4 is x squared minus 8x plus 16. X plus 2 times x minus 2 is x squared minus 4. So these are our new fractions. Now we will subtract the numerators. So I've got the same common denominator. I've got x squared minus 8x plus 16. And this minus changes the sign of everything in the second fraction. So I have negative x squared plus 4. Now I will simplify. I've got x squared minus x squared. Those cancel out. I have negative x squared, and then 16 plus 4 is 20. So I have negative 8x plus 20 over x plus 4 times x minus 2 times x minus 4. So let's see if we can simplify this. So negative x plus 20. What can I factor out of that? Do I have a common factor? I can factor out a negative 4. And then what I'd be left with, negative 4 times what is negative 8x? 2x. Negative 4 times what is 20? Negative 5. So our numerator of negative 8x plus 20 can become negative 4 times 2x minus 5. I still have my old denominator, and there are no common factors to cancel. So that's my answer.